Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. We need to count the total number of stereoisomers for each compound. Concept for compounds with multiple double bonds, EZ isomerism, or stereocenters, chiral centers, CIS trans in rings. Count all possible stereoisomers is equal to 2n, where n is equal to number of independent stereoelements, then subtract for any internal symmetry or constraints. Dash. A. CH3, CH is equal to CH, CH is equal to NO, but 2N1 alloxime or crotonaldehyde oxime. This molecule has two double bonds that can show geometric isomerism. 1. CH3, CH is equal to CH, E or Z, CIS trans. 2. CH is equal to NO, E or Z, SYN anti. Total is equal to 2 times 2 equals 4 stereoisomers matches, Q. Dash. B. 1, 3, 5, trimethylcyclohexane. The molecule has 3 stereocenters, C1, C3, C5, each bearing a methyl group on the ring. However, due to the molecular symmetry, C3V like many combinations are identical. Possible configurations. All 3 methyls CIS, all up or all down, these two are mirror images of each other, but the molecule has a plane of symmetry when all are on same side. Actually, the all CIS isomer 1, 3, 5 CIS, CIS, CIS is a chiral, has a plane of symmetry. That counts as one isomer. 2 up, 1 down, and 2 down, 1 up due to the threefold symmetry of the ring. All 2 up, 1 down arrangements are equivalent. The resulting molecule is chiral, gives 1 pair of enantiomers is equal to 2 isomers. Total distinct stereoisomers is equal to 1, all CIS, mesolike achiral, plus 2, enantiomeric pair, is equal to, but wait, reconsidering, all CIS gives 1, achiral, the mixed arrangement gives an enantiomeric pair is equal to 2. So total is equal to 1 plus 1 equals to distinct stereoisomers. Actually, the standard result for 1, 3, 5 trimethylcyclohexane, there are 2 stereoisomers total, the all CIS, achiral, and the 1, 3 CIS, 5 trans, which exists as one achiral form due to the plane of symmetry through C5. This gives total is equal to 2 stereoisomers matches, P. Dash. C. CH3, CH is equal to CH, CH is equal to CH, CH is equal to CH, CH3, octa 2, 4, 6, trying. This compound has 3 C is equal to C double bonds, each capable of EZ isomerism. 1. C2 is equal to C3, E or Z, 2. C4 is equal to C5, E or Z, 3. C6 is equal to C7, E or Z, maximum is equal to 3 is equal to 8, but we check for any that become identical due to symmetry. The molecule has a symmetric structure, CH3 on both ends, so some isomers may be identical. The symmetric nature means that swapping configurations of bond 1 and bond 3 simultaneously may give the same compound. After accounting for symmetry, 8 halves plus symmetric ones is equal to 6 distinct stereoisomers matches are. Specifically, E, ZZZ, these are symmetric, each unique, is equal to 2, EZ is equal to Z, same due to symmetry, is equal to 1 pair counted as 2 structures, but they are identical, so EZ gives 1, ZZE is equal to EZZ1, EZE1, ZEZ1. Total is equal to 2 plus 1 plus 1 plus 1 plus 1 equals 6 stereoisomers. Dash. D. CH3, CH is equal to CH, CH is equal to CH, CH is equal to CHPH, 1 phenylhepta 1, 3, 5 triene or similar. This compound also has 3C is equal to C double bonds capable of EZ isomerism. 1. First C is equal to C, E or Z, 2. Second C is equal to C, E or Z, 3. Third C is equal to C, E or Z. Now the molecule is asymmetric. One end is CH3, other end is pH, so no two isomers coincide due to molecular symmetry. Total is equal to 3 is equal to 8 stereoisomers matches S. Dash. Summary of matches. A. Q4 stereoisomers. B. P2 stereoisomers. C. R6 stereoisomers. D. S8 stereoisomers. Therefore, the correct answer is AQ, BP, CR, DS. The correct answer is shown on screen.